Okay, chapter 11. We'll start with homework question 1. We've got two vectors. They're just arbitrary. We have a 3i plus 4j for our a vector, and we have a b vector of negative I, or negative 1i, plus 2j. For part A, it wants us to calculate out what the cross product is of a cross b, and for part B, it wants us to calculate what the angle is between a and b. Okay, so for the first part, we need to figure out how we're going to do our cross product. Okay, so the way that I usually like to do them is written out like this, where I have I, J, K, and then I repeat I, J, K. So that's my directions up top, my X, Y, Z's. And then order matters when you calculate cross products. So I have A crossed with B, which means A needs to come first. So I'm going to have A, and if we read from the top, it is 3I, 4J, 0K. And then I just repeat it again, 3, 4, 0. Vector B, same thing. We have a negative 1 plus 2. So I'll have a negative 1i plus 2j and a 0 for the k. And then repeat again. Now, if you're going to do a cross product, okay, usually think about drawing an x. If you draw an x, you usually start here and you come down across this, right? You come down for your first cross, then you go over and you come up for the other one. So that's how we'll start. We're going to go here and we're going to go down. So I'm going to start with the i's. It's also another thing you can just remember. Always start with your direction. So if I start for i's and I come down in my cross, I get 4 times 0. 4 times 0 then, of course, would be 0i. I then do j and I get a 0 times negative 1. So again, I'm going to get a 0 for j. But for k, I get a 3 times 2. 3 times 2 will give me a 6. Okay, so k hat, 3 times 2 gives me a 6. Now I've got an ijk, so I'm done with this motion of the cross. Okay, I'm done with the downward motion. Now I got to come and I got to go up. So that's exactly what I do here. I start with the negative 1, the bottom corner, and I work my way back up. I have a negative 1 times 4, and that's k. So negative 4k. Okay, I have 2 times 0 times I, so I have a 0i. And then I have a 0 times 3 times j. So 0j. Okay. Now on the up, you have to do a minus sign. Okay, so it would be this set of 3 on the downward stroke minus these on the upward stroke. So in our case, we have zeros for both of the i's, we have zeros for both of the j's, and we have 6 minus a negative 4. So that's the same as 6 plus 4. So we should end up with 0i plus 0j and 10k. Now, normally you don't write the i's, the 0 component, so we could just keep that as a 10k. Okay? And that's our answer for up here, too, as well. 10k, so we know we're right. The second part got a little more complicated. I did this once before, and I got a little whoopsie there. Forgot it was supposed to be sine. So even the professors make mistakes here. Calculate the angle between the vectors a and b. Okay, it's a cross product. I mistook it for a dot product. A cross product would be magnitude of a times magnitude of b times the sine of the angle. Okay, because you want that to be at 90 degrees for its maximum. AB sine theta. Okay, so for that, I need to figure out what the magnitude is of a cross b. So here we got 10k, which is great because it's just the one number, it's just the one direction. So our magnitude is just 10. If there were other components in here, like an I and a j, for instance, you would need to use Pythagorean theorem on the 3 components to get the magnitude. Okay, but the square root of 10 squared is just 10, so we can use that as our a cross b. So I'm going to put this up here. So I have a cross b is equal to magnitude of a times magnitude of b times the sine of theta. A cross b, the magnitude of that is going to be 10. Okay. Magnitude of a. Okay, so we'll have a up here. A is equal to 3i plus 4j. So if I take Pythagorean, I'm going to have 3 squared plus 4 squared. That's 25. Square root of 25 is 5. So that's the magnitude of a. Magnitude of b would be negative 1 squared plus 2 squared. So that's square root 5. That's b, square root of 5. And angle, well, that's what we're trying to find, sine theta. So if I divide both sides by 5, this will knock it down to 2. And then if I divide it out by root 5, I will have 2 over square root 5 is equal to sine theta. Okay, so to get that by itself, to get theta by itself, take an inverse sine. Inverse sine of 2 over root 5 would be equal to theta. And if we do that calculation out, we get the answer that we would expect to get, where theta then is equal to 63. It has to be rounded, but 63.4 degrees. Okay. So that's how we get the answers for question 1.